Here is the next example. He's asking us to solve this example by using the mesh analysis. Okay, so step one, assign all the loop current. So assigned loop 1 as I1, loop 2 as I2, loop 3 as I3. So loop 1 here, loop 2 and loop 3, three loops. So loop 1, do we need to apply KVL? So to check that, check is there any current source in the outer branch of that loop. So the outer branch, here is my outer branch. Is there any current source? No. Here is another outer branch. Is there any current source? No. Here is another outer branch. No current source. So then we need to apply KVL. If there is no current source in the outer branch, we need to apply KVL. So minus 40, because I'm entering the negative terminal, minus 40 plus 30 I1 plus 30 I1. I mean, before doing this, my apology, you need to assign positive and negative sign. So how do we assign positive and negative signs? Start walking from one point and go over each element, come back to the same point. If it is a resistor, when you are entering, assign that as a positive, leaving that, assign that as a negative, because resistor always consume electrical energy. Basically it converts electrical energy into heat and light energy. So since it is consuming electrical energy, we'll take that as positive when we are entering into that element. Okay, once we assign, now I'm going to write down the equation. Minus 40 for the voltage source is already given. We never assign positive and negative signs for the voltage source. So minus 40 plus 30 times I1 plus 30 times I1 minus I2 equal to 0. So I ended up with 60 I1 minus 30 I2 equal to 40. Okay, now when it comes to loop 2, okay, let me write it down, loop 2 here. So if I apply loop 2, do we have any current source in the outer branch? Outer branch is only this 10 ohms and this empty branch. I don't see any current source, so for sure we need to apply KVL. But if I try to apply KVL, before applying KVL, assign positive and negative signs. So plus minus, this is a current source. For the current source, head is always positive, tail is always negative. So loop 2, if I write it down, plus 10 times I2 plus, so 10 times I2. Now 10 is the resistance, I2 is the current. So when I'm applying KVL, Kirchhoff's voltage law, I'm adding the voltages in the loop. So 10 is resistance, I is the current, so I times R, that's the voltage basically. Okay, so that's the voltage here, and this is current. Can I add the current? No. I mean, I saw people writing this as a 10 I2 plus 2 plus 30 times I2 minus I1, which is wrong, because this is voltage and that's current. You cannot add voltage and current. So here it is kind of hard to find the voltage across this 2 ampere current source. So in this case, what we're going to do, we're going to do a super mesh analysis. A super mesh analysis is nothing but if there is a current source between two meshes, then write super mesh equation. So here I have two loops. I have a current source between two loops. So start writing super mesh analysis. So super mesh is nothing but you're going to go over two loops basically. Come back to the same point, going through two loops. So here 10 I2 plus 10 I3. So 10 I2 plus 10 I3 plus 30 I2 minus I1 equal to 0. Now when I simplify this, I end up with minus 30 I1 plus 40 I2 plus 10 I3 equal to 0. That's my second equation. Now for every super loop, you will end up with a very big equation like this, and big equation like this, and then you will end up with a small equation similar to the nodal analysis. So small equation is, if you look at this current source, 2 ampere current source, I just wrote it down here. I2 is coming down, I3 is going up, but the current source is 2 ampere. Okay, so the 2 ampere and I3, they both are in the same direction, so I3 must be higher. So I can say I3 minus I2 equal to 2 amperes. So that's my third equation. So what I did, I substituted this third equation into second equation to eliminate I3. Eliminated I3 here. Okay, so I end up with fourth equation, minus 30 I1 plus 50 I2 equal to minus 20. I'm multiplying this with the 2, so I end up with minus 60 I1. So when I multiply with 2, minus 60 I1 plus 100 I2 equal to minus 40. What I did, this is my first equation. Now I took first and the fourth equations after multiplication. I'm adding those two. So 70 I2 equal to 0. So I end up with I2 equal to 0. When I2 is 0, I3 equal to 2. From there I can find I1 equal to 2 by 3 amperes. So Ix is nothing but I1 minus I2. So 2 by 3 minus 0, which is 2 by 3 amperes. That's the Ix. So a super mesh analysis is nothing but if there is a when there is a current source between two meshes, we'll solve it by using super mesh analysis. In the next video, I'm going to solve a couple of more examples. Thank you.